Hello students, today I am going to discussing about compound pendulum and bar pendulum. What do you mean by compound pendulum? A compound pendulum is a rigid body capable of oscillating freely in a vertical plane about a horizontal axis passing through it is called compound pendulum. Look at this figure. The center of suspension of pendulum is the point in which the axis of rotation meets the vertical plane through the center of the gravity of the pendulum. As the definition of the compound pendulum says that a rigid body capable of oscillating freely in a vertical plane about a horizontal axis passing through it. That figure shows that the vertical section of the rigid body capable of oscillating about a horizontal axis that is S here. This point is S. The S center of suspension, that means S is the center of suspension. Suppose just consider G is the center of gravity. This point G is the center of gravity of the body lying vertical below S. The distance between S and G, you just imagine that is the length is L in its normal position of rest. Okay. Suppose if the body is displaced through an angle theta, the body is displaced through an angle theta, its center of gravity is G. Okay, center of gravity is G. The weight of the body, the weight of this body is, just assume that is the mg. The weight of the body is mg, and its reaction at the supports constitute a couple of given center of gravity. That means, I will repeat the once again here. Suppose if the body is displaced through an angle, suppose this body is displaced through an angle theta, its center of gravity point, that G is the center of gravity at the point, assume that is depend upon the mass into gravity, that is mg, and its reaction at the support constitute a couple of given by that is center of gravity, that is that point C is equal to minus mg L sin theta, because the center of gravity, the value center of gravity of that body is mg, and L sin theta, because you just assume that, I just look at this figure here, just assume that the body is moving from here to here. Okay, the angle of the displacement is just theta, and the distance between the center of gravity C2 and original point is just that is depend upon that you just assume that this is a triangle, this is the hypotenuse, sin theta of hypotenuse, that is L sin theta. Why I am taking the negative here? The negative sign indicates that the acceleration is directed towards mean position, directed towards the mean position. Suppose now let the moment of inertia of the pendulum about an axis passing through the S. What is the moment of inertia? The body is passing through the S, and it is perpendicular to its length is I. The angular acceleration may be written as here d square theta by dt square. That is always equal to the body move from here to here, that is C point, that is mgl sin theta. The moment of inertia of that body is equal to, that is I into d square theta by dt square is equal to minus mgl sin theta. Okay, as I told that this negative sign indicates that the acceleration is directed towards the mean position. Just take this entire term to this side. Okay, that is I into d square theta by dt square plus mgl sin theta is equal to 0. Okay, now just assume that For a small angle displacement, the body is moving here. There is a very small angle. This is moving here to C value, a small angle. Then sin theta is equal to theta. Sin theta is equal to theta. Just substitute this theta value here. Okay, sin theta is equal to theta here. That remaining the I d square theta by dt square plus mgl, keep it as it is. Instead of sin theta, just write it as theta only, is equal to 0. Then that displacement always depend upon the moment of inertia. The moment of inertia of the pendulum about the axis passing through the S and perpendicular to its plane is always equal to the mass into that is radius of gyration and length of that body. Length of that body, that is equal to the mk square plus ml square. Okay, here what do you mean by k? K is the radius of gyration about an axis passing through the center of gravity of the pendulum here. Here take the m is outside here, that remaining is the m into k square plus l square. This mk square plus ml square is nothing but a moment of inertia. That is value, that is the I. I is the mk square plus ml square. Just substitute the I value here. Okay, substitute the I value here, that is m into k square plus l square d square theta by dt square, keep it as it is, plus mgl sin theta is equal to 0. Okay, in this equation just divide by m into k square plus l square for whole equation. For this equation, what we want to do now, divide by m into k square plus l square. Okay, here m into k square l square get cancelled here. Then remaining only d square theta by dt square, keep it as it is, plus here 1 m and m get cancelled here. The remaining numerator is only gl divided by k square l square into theta. Just call it as a, this equation is 1. Okay, now this equation is equal to the simple harmonic motion equation. What do you mean by simple harmonic equation? As we already know that d square y by dt square plus omega square y is equal to 0. Okay, just comparing this equation 1 and equation 2, that is d square, instead of here y is refers to the angle of displacement, y is equal to theta here. Okay, d square theta by dt square, okay, d square theta by dt square and d square y by dt square is called same, plus omega square into theta. Here instead of omega square, what is there here? Lg divided by k square plus l square. Okay, omega square is the Lg divided by k square plus l square, where omega is the, as we already know that omega is the angular frequency, or omega is the angular frequency. That, as we already know that the time period is we know that t is equal to 2 pi by omega, that is the standard formula. Just substitute that omega here. Okay, substitute omega value here, that is t is equal to 2 pi into square root, just some square root of, that is because here omega square is there, just t is equal to 2 pi, keep it as it is here. Then k square, just take the numerator here, that is omega is Lg by k square plus omega square, that's k square plus l square divided by Lg. Okay, this is called as equation number 3, and just you can finish it here itself, no problem, or just here also just take the common factor, that is L square is divided by L here, just divided by L here, both the equation here, k square by L plus L divided by G, L get cancelled here. Okay, this is the equation 3. Okay, I will repeat once again here. What do you mean by compound pendulum? Compound pendulum is the rigid body. It is capable of oscillating freely in a vertical plane about horizontal axis passing through it. Okay, the how is show as shown in the figure here. The vertical section of the rigid body capable of oscillating about a horizontal axis through the S here. The center of gravity G, that value is mass into gravity, and the if the body displaced through an angle theta, its center of gravity G takes place the position mg. Suppose the weight of the body mg and its reaction at the support constitute a couple given by, that is minus mg L sin theta. Mg is the, that is center of gravity value, and L is the L sin theta, that is nothing but a, this is nothing but a triangle here. Okay, the value of, as we already know that one side value here, that is the opposite by hypotenuse. Okay, opposite by hypotenuse, that is opposite value is L, and theta and sine of theta, that angle is sine of theta, that L into sine theta. Just I am writing as it is here. Okay, suppose the moment of inertia of this body compound pendulum, that is depend upon the angular acceleration, that way angular acceleration is written as d square theta by dt square, and moment of inertia of that angular acceleration, that is I into d square theta by dt square is equal to minus mgl sin theta. Okay, this is the minus term, take it completely this side. Okay, I into d square theta by dt square plus mgl sin theta is equal to 0. Okay, suppose the displacement of that body is very small in that time, just assume that sin theta is equal to theta. Sin theta is equal to theta. This substitutes sin theta is equal to theta value here, just here. Okay, therefore I into moment of inertia into d square theta by dt square plus mgl theta is equal to 0. The moment of inertia of the pendulum about an axis passing through the S is S and perpendicular to its plane. Okay, that is we can write it a moment of inertia, we can write as mk square plus ml square. Here k is the radius of gyration about an axis passing through the center of gravity. Okay, just substitute, this is the moment of inertia value, this substitute the value here. Okay, substitute the value here, that is instead of I, that is m into k square plus l square d square theta by dt square plus mgl theta is equal to 0. Okay, in this equation just divide by both the term m into k square by l square. Okay, here this m into k square by l square get cancelled here, remaining only first term here, that is d square theta by dt square plus m get cancelled here, only gl is remaining here, gl theta remaining here, divided by k square plus l square is equal to 0. This equation is equal to the equation of this simple harmonic motion, that is d square y by dt square plus omega square y is equal to 0. Okay, here the y refers the angular displacement, that is nothing but a theta. This omega square is equal to the Lg by k square plus L square. But here, as we already know that angular velocity t is equal to t 2 pi by omega, but we know that here that is the omega square here. I need to substitute the only omega. Okay, that is nothing, omega is equal to square root of Lg by k square plus L square. Okay, 2 pi keep it as it is, omega square, that is 1 divided by Lg divided by k square plus L square, just k square plus L square go to the numerator, that is 2 pi into square root of k square plus L square divided by Lg. You can finish it here, or we can write it continually with the numerator and denominator, there is a L term, just remove the L term here, both the equation divided by L. Okay, k square by L plus L square and L get cancelled, remaining only one L here, and L get cancelled here. This is the equation for theory of compound pendulum. Okay, is there any doubt? Please let me know. Send a message in the WhatsApp, any doubt. Okay, thank you.